So hello everyone and welcome dear all in mathematics class today here, and we are going to study the topic that rotational symmetry. Okay, and here we will see the different phases during a rotation done by a figure. Here I have shown by square and the equilateral triangle the different phases it takes during the complete rotation, and we will see that how many times it takes its original shape. That means it fit onto its original shape during the complete rotation. Okay, so first we have to understand this, that what is rotational symmetry. That we can say a figure is said to have rotational symmetry if it fits onto itself more than once during one complete rotation. More than once. Okay, so just like this is one of the example, that equilateral triangle original form given here, and when it is rotated through 120-degree rotation it takes its original shape again. So we can say that the equilateral triangle has the rotational symmetry. So now what is the order of rotational symmetry for any figure? That will be defined as like this: the number of times a figure fits onto itself. How many times you have to count in one complete rotation is called the order of rotational symmetry. Okay, so now for understanding this, let us rotate an equilateral triangle through the given angles 120 degree, 240 degree and 360 degree. So this is the original form of the figure, and it is rotated through first 120 degree, then next 240 degree rotation, here rotated through 120, and then here rotated through 240 degree, and now at the last rotated through again 120 degree. So each time it rotates through 120 degree, first 120 degree rotation, second 120 degree, and again 120. So total you will count that 120 into 3, that means 360 degree rotation done. So in this way, in each rotation you will see that it is taking its original shape, that means original form. So the equilateral triangle has the order of rotational symmetry is 3. Its order is 3 for the rotational symmetry. Okay, in other figures also we can define the order of rotational symmetry for the equilateral triangle. Here it is rotated through 120, and now again rotated through 120 here, that means total 240, and at the last rotated through 120 here, you can see that is total 360 degree rotation. So we can say that clearly each of the 3 times figure fits onto itself, the equilateral triangle figure, means the equilateral triangle has the rotational symmetry of order 3. Okay, now order of rotational symmetry of a square. For understanding these, you have to rotate a square through the angles 90 degree, 180 degree, 270 degree and 360 degree. That means each time you have to increase the angle by 90 degree for the rotation. So you will see that this is the original form, and when this diagram is rotated, this original form rotated through 90 degree, it takes this original shape again. That means it will fit onto its original figure on the original shape, and again rotated through 180 degree, the diagram will look like this only. Okay, the sides rotation you can see here, it is rotated through clockwise direction. Okay, because AB comes this side, this side, and again rotated through clockwise direction here, and then here again rotated 120 90 degree increase, that means 270 degree rotation, and at the last rotated to 360 degree, and each of these 90 degree, 180 degree, 270 degree and 360 degree, each of these times we see that the figure fits onto its original shape. That means it has the order of rotational symmetry is 4. The 0 degree rotation you will not count that, excluding the 0 degree, means 90 degree, 180 degree, 270 degree and 360 degree rotation. Each of these times the figure fits onto its original shape, means it has the order of rotational symmetry is 4 here. So clearly each of the 4 times the figure fits onto itself, and so a square has the rotational symmetry of order 4. Okay, so now you may solve the exercise 18b. You can do question number 2 to 10 there and complete that, and also revise this rotational symmetry nicely for the different figures, and count the order of rotational symmetry. Find out the order of rotational symmetry by doing the rotation. Okay, so thank you all of you here, and watch this nicely to understand all the points. Okay, and have a nice day.